Dear learners, in this video, I am going to explain you what happens at divergent boundaries or constructive margins. This illustrates the separation of two oceanic plates to form new oceanic lithosphere. The hot asthenosphere underneath is carrying the two plates apart, and as the rising mantle rock melts, magma is injected between the plates to create new crust and lithosphere. Divergence or constructive margins are often marked by ocean ridges, that is, or for example, the Mid Atlantic ridge and the East Pacific rise. The rising magma forms submarine volcanoes which in time may grow above sea level. For example, Iceland, Tristan da Cunha and Ascension Island on the Mid-Atlantic rise and Easter Island on the East Pacific rise. Different rates of latitudinal movement along the boundary cause transform faults to develop as the magma cools. These lie perpendicular at a right angle to the plate boundary. Most of the earthquake activity at a constructive margin is shallow, low magnitude and high frequency, often along transform faults as the mid-ocean ridge is offset. In June 2000, a significant earthquake 6.5 mm occurred on the south coast of Iceland. The average depth of the seafloor is about 4 km. But mid-ocean ridges are significantly shallower, approximately 2.5 km. The reason for this is that the ridge lithosphere is significantly hotter than average ocean lithosphere. Hotter lithosphere is less dense, less compact, and so it rides higher on the underlying asthenosphere. The oceanic plates grow at the oceanic ridge. As a plate moves away from the ridge, new basaltic crust is added to the trailing edge and older crust is carried away, much like the action of a conveyor belt. As the lithosphere moves slowly away from the ridge crest, it cools and shrinks, and thus the ocean floor gets progressively deeper away from the ridge until it is old and cold, and as much as 5 to 6 km deep. The youngest ocean floor in all the ocean is found at mid-ocean ridges, and the oldest lithosphere is typically far away from the ridge where it formed. Oceanic plates grow at ocean ridges and are consumed into the mantle when they are subducted at a convergent boundary. Dear learners, now I will explain you what happens when divergence splits a continent apart. This illustrates the activity that accompanies continental rifting or breakup, where hot asthenosphere rises up beneath a continent, the crust heats up and weakens and gradually begins faulting and breaking apart. Basaltic magma generated by melting of the rising asthenosphere intrudes into the faulted zone and commonly erupts into the basins formed between faults. Also, deep lakes may form in these rift valleys, such as Lake Tanganyika and Lake Victoria in East Africa. In many, but not all cases, the continent rifts apart and a new ocean basin and mid-ocean ridge forms between the diverging plates. The Red Sea, which separates Africa and Saudi Arabia, is a good example of a juvenile ocean basin. Early stages of rifting occur along the East African Rift, a long continental rift that begins near the Red Sea and extends into the Central Africa. The rift is within an elevated, means uplifted region and has several different segments, each featuring a downdropped rift. Some parts of the rift contain large lakes. The East African rift is topographically lower than its flanks but contains numerous active volcanoes is represented by this mountain within the rift. Volcanoes are especially common in the Afar region of Ethiopia, located where the rift joins the Red Sea. The Afar region is one of the most volcanically active regions on the planet.